This is the VU Calculus class. We're doing topic 2, which is limits algebraically, and this is video 2 in the series. So now we're going to do examples 4, 5, and 6 before you do some practice problems. So in example 4, we're given the limit as x approaches 2 of this crazy, awesome monstrosity of fractions, x plus 2 all over a 2, minus a 2, and then that whole thing over an x minus 2. So first thing I'm going to do is plug in, because every once in a while, no matter how disgusting something looks, when you plug in, you get a number and you're done, and that's awesome. When I plug in, I get 4 over 2 minus a 2, and on the bottom I get 2 minus 2. So the answer seems to be 0 over 0, which is, of course, not the answer, right? That's not ever the answer, right? So what that means is I'm going to have to simplify because that's not my answer. So here, factoring is not my best plan, right? Factoring is great if you have polynomial over polynomial because when you factor them, something might cancel. But here, I've got a fraction in a fraction, and I should probably start by dealing with getting a common denominator. So I'm basically going to let the x minus 2 just chill for the moment and deal with the fact that the numerator is the uglier part of this situation, right? So I have this x plus 2 all over 2 minus a 2 over 1. And I'm just going to leave the numerator to chill, and I'm going to deal with getting a common denominator in my numerator. This guy's denominator is a 2, this guy's denominator is a 1. To get the easiest common denominator, I just need a 2, right? I can just multiply by 2 over 2, right? And I'm allowed to do that because it's the same as multiplying by 1. So what that's going to mean, and notice I'm still writing limit because when there are x's, I still need to write limit. It's going to be the limit as x approaches 2. This is now going to be an x plus 2 minus 4. X plus 2 minus 4, all on top of a 2, all over this x minus 2 that's still just chilling, right? Like I haven't messed with the x minus 2 at all. Well, when I clean up the numerator, I think that's an x minus 2. So I think I get that this is the limit as x approaches 2 of x minus 2 over 2 divided by, and now's a good time to remember that this x minus 2 is actually over 1, because every fraction is always over a number. If it looks like it's not over anything, it's actually over 1. So when we divide by a fraction, so we essentially have fraction divided by fraction, we flip and multiply by the reciprocal. So this is going to be the limit as x approaches 2 of my numerator, x minus 2 all over 2, times the reciprocal of the denominator, which would be a 1 over x minus 2. Well, what I want you to notice is that there's now a factor that cancels out of this, right? And if you need to see it, if you need to write it a little bit better, if you need to write this as an x minus 2 on the top and a 2 times an x minus 2 on the bottom, or if you want to write a 1, it doesn't matter to me. The x minus 2's, which are totally my problem factor, they're the thing that's making these things be 0, they cancel, and I get that this is just the limit as x approaches 2 of 1/2. And you might say, well, okay, that's cool, but where the heck do I plug in the x? And the answer is you don't. This is a constant function. The answer is just 1/2, because there is nowhere to plug in the x, so regardless of what x value you have, the limit would be approaching a 1/2. So that's your answer, and that's example 4. We're going to walk through example 5 and 6. And then you're going to have some practice problems. So for example 5, we have another fraction. So example 5, we have the limit as x approaches 0 of 1 over x plus 2 minus 1 over 2 all over an x. And I'm basically in the exact same situation I was in the last problem. You can plug in first, that's absolutely fine, but you're going to get 1/2 minus 1/2 on the top, and you're straight up going to get a 0 on the bottom. So you're going to end up with 0 over 0, which again is not ever for the rest of eternity going to be the answer. So please don't say that's the answer. So again, I really want to get a common denominator. Now, a thing to keep in mind is that these are factors, right? In order to get a common denominator, I need the least common multiple of these factors. So you can't just like add an x to the top and bottom because that's not how it works. The bottom would not become an x plus 2 and the top is an x. That's not how it works. So I'm going to have to times x plus 2 on the top and bottom of this expression, and I'm going to have to times by 2 on the top and bottom of this expression. I'm just going to leave the x on the bottom chilling because he's not my issue right now. So there's not really much way you can simplify that x, so it makes more sense to simplify the problematic thing. So I'm going to get a 2, and then this will be minus the quantity x plus 2, all over a 2 times an x plus 2, all over an x. So let's clean that numerator up. Notice again that I'm still writing limit as x approaches 0. When I distribute, I think this becomes 2 minus x minus 2, so I think I just get a negative x on top of this 2x plus 4, and you could change it from a 2x plus 4 if you want. And then on top of, the whole thing's on top of an x, but I'm going to call that an x over 1, because every number is actually secretly a fraction. The number 5 is 5 over 1. The number 37 is 37 over 1, right? Everything's secretly a fraction. So when we divide a fraction by a fraction, we flip and multiply by the reciprocal. So I'm going to get negative x over a 2x plus 4 times a 1 over x. Well, what you'll notice is that these factors can now cancel. And I'm going to get that this is the limit as x approaches 0 of a negative 1 on top of 2x plus 4. So when I plug in, I stop writing limit. I'm going to get negative 1 on top of 0 plus 4. And my answer is a negative 1/4. Okay? Last but not least, we're going to do one with some square roots. Good times. So in example 6, we have the limit as x approaches 9 of x minus 9 on top of a square root of x minus 5 all minus a 2. Notice the 2 is not inside the square root. Okay, so the first thing we should always do is plug in, right? When I plug in, I get 9 minus 9 on the top, which is already a bad sign. And on the bottom, I get root 4 minus 2, which is totally 0 over 0. So again, not the answer. So this is a hint I have to simplify, but now you're going to have to do something you probably feel less comfortable with, and that thing is called rationalizing. So we frequently rationalize with numbers, okay? So when we're asked to rationalize with numbers, like if I gave you a 1 over a root 3, the way you would rationalize is by timesing by root 3 over root 3, right? And you'd end up with an answer that is root 3 over 3. Right? Or I could give you something harder to rationalize. And again, that's not this exact example. I just want to show you what we mean. Sometimes we're asked to rationalize things like a root 3 plus a root 5. Well, the way we rationalize that is actually by creating what we call a difference of squares. So I would make this root 3 minus root 5 and a root 3 minus root 5. And what would end up happening is the top would stay root 3 minus root 5. But when I FOIL the bottom, the outer would become a 3, right? Because it would be root 3 times root 3. The first would become a 3, sorry. The outer and inner would cancel because they would both be root 15s. They'd be a positive root 15 and a negative root 15, so they'd cancel. And then I'd get a minus 5. So what ends up happening is I end up with an answer that doesn't have a root in the bottom. That's rationalized, okay? So again, I didn't show you this because that's this specific problem. I showed you this because that's what we're going to have to do here, but we're going to have to do it with x's. We're going to have to do this skill where we create a difference of squares. So when we rationalize, what we want to do is we want to take the floor that has the root, right? And when we say rationalize, what we want to do is we want to create a difference of squares pattern, right? So a minus b times a plus b, which becomes a squared minus b squared, right? That's what we want to do. So that's what we're going to do right here, okay? So I'm going to go ahead and take this limit. This is the limit as x approaches 9 of this x minus 9 quantity. On the bottom, I have root x plus or minus 5 minus a 2. This is my a minus b. My a is the whole root, and my b is the 2. What I want to do is I want to create this difference of squares pattern by multiplying by a plus b, which in this case is going to be that whole root, the root x minus 5, plus a 2. And I have to do that on the top and the bottom because that's how it works. If you want to change an expression, you still have to multiply it by 1, no other number. Okay, so what's going to happen when I do this is I want to FOIL out the difference of squares. Okay, I want to FOIL out the difference of squares floor, whichever that is. But I don't want to FOIL, so don't distribute the other floor. And I'm going to show you why, but the short answer is that I need to cancel this x minus 9. And if I FOIL that, it's going to be harder to cancel. So now what's going to happen down here is I'm going to get the limit as x approaches 9. I'm going to keep this as an x minus 9 times this ugly root x minus 5 plus a 2, okay? On the bottom, when I FOIL, my a squared, right, because it's going to FOIL into a difference of squares, a squared minus b squared. Root x minus 5 times root x minus 5 is going to give me an x minus 5, no more root. The outer and inner will cancel. The outer will be a 2 root x minus 5. The inner will be a negative 2 root x minus 5, meaning they are the same thing, but different signs. That's the purpose of this difference of squares. It will cancel out that part. And then the back seat, the L in FOIL, is going to be a negative 2 times a positive 2, which is a negative 4. So what I want you to notice is it's not an accident that this denominator became x minus 5 minus 4, which is absolutely an x minus 9. So what's about to happen is that this factor, this guy right here, is actually an x minus 9. They're going to cancel. And all I have to do is plug into the only factor that's left. So I now have the limit as x approaches 9 of this root x minus 5, all plus a 2. Well, that, when I stop writing limit, because I'm about to plug in, is going to be a root 4 plus a 2, which is 2 plus 2, or 4. And that's my final answer. So, again, this is rationalizing to essentially create a difference of squares to get rid of the root. And that's example 6. So you're going to try problems 1 through 6 now to see how you feel on this.